All right, copper 2 sulfate hydrate lab. Copper 2 sulfate, CuSO4, 5 H2Os. That's this. Okay, copper 2 sulfate, and let me show you what it looks like because it's my favorite thing to do. Ooh, isn't it pretty? What? What is it? It's a salt. It doesn't have a smell. Okay, it's a salt. Yeah, you cannot eat it. Well, like I always like to say, you can eat it once, and then you can't anymore because it's poisonous. So don't eat it. No, you're not going to breathe it in. All right, so the copper 2 sulfate pentahydrate, this is a hydrated salt. Okay, when I say hydrated salt, I mean that it has the salt and the water. Okay, that's what hydrate means. You have in your box here 3 things, very exciting times. You've got this thing, which is called an evaporating dish. It's just a porcelain dish. Okay, it will break if you drop it. You have a set of beaker tongs, and you have a glass stirring rod. Those are the 3 things you have in your bucket. Okay? This evaporating dish is going to be used to hold the copper 2 sulfate pentahydrate. So when you get your lab, and I'm going to give you a copy of the lab, you're going to measure the mass of this evaporating dish. That's the first thing you do. And I said that last period, and I still had people coming up to me, and I said to them, did you measure it? And they said, oh no, I forgot. What's the first thing you do? Measure the mass of the evaporating dish. All right, so the evaporating dish, for now on, it's going to be written ED, evaporating dish. Okay, so I don't have to write it out anymore. And let's say that evaporating dish weighs 54 grams. Everybody's evaporating dish is going to weigh a different amount. Okay? All right, then you're going to come up to me after you get that, and I'm going to say to you, did you measure it? And you're going to say yes. And then I'm going to give you some of this hydrated salt. And the hydrated salt I'm going to give you is about this much. Okay? Somewhere around there. And then you're going to walk over to your lab table. You're going to go doot over to your lab table. You're going to measure the evaporating dish and the hydrated salt. So we're going to have the evaporating dish and the hydrate. Is it going to weigh more or less than 54 grams? More. If it doesn't, you measured something wrong. Okay? So I'm going to make up a number. Let's say it weighs 146 grams. It's not going to weigh 146 grams. That's a number I made up. Everybody with me? Yeah. Okay. Now, you know what? I'm going to hand out the lab. All right, back in business. Everybody has a copy of the lab now. So, our objective, what we're trying to do, is we're trying to determine the percent of water in the hydrate, and we're going to calculate its percent error eventually. You should get pretty close. Okay? So your percent error should be very low if you did everything right. If you did the math right, if you did the measuring right, if you did... This lab, you can get a very low percent error. All right, you need a porcelain evaporating dish, I wrote evaporating dish twice. Tongs, glass rod, hot plate, and electronic balance. The electronic balance and the hot plate are on your lab tables already. All right, if you turn the page, there's 2 charts. There's one at the bottom of the first page, and then there's one at the top of the 3rd page. The one on the 2nd page says mass of anhydrous salt and evaporating dish. Okay. This is the number that you're going to get after you start heating this thing up. Okay, so let's backtrack just a little bit. You measured the empty dish, you measured the dish with the blue stuff in it. Now you're going to go and you're going to heat this up. Okay? When you heat it up, this blue salt is going to turn into like a white ashy color. Okay? That's how you're gonna kind of know you're getting close to being done. Take the glass stirring rod and move it around so it hits all of the hot porcelain, and it's going to get ashy in color. Take it off the hot plate using your tongs, like this. Put it on the lab table, cool it off. Once it's cooled off, you're going to go and you're going to measure it. Then you're going to do it again. You're going to put this back on the hot plate. You're going to take it off. You're going to let it cool. And you're going to measure it again. And the reason for that, see where it says first heating, second heating? Let's say we get 112.88 grams here. Actually, let's say we have 112.95 grams here. Okay, and then you heat it again and you get 112.88 grams. Do you see how this went down in value? That means there was still water that came out of that salt. You need to heat them at least 2 times, maybe 3, maybe 4, until this number stays the same. When that number stays the same, now you know that all of your water is out of your salt. Capiche? Okay, so that's that. So, over here, mass of our evaporating dish. We said 54, where's my pen? 54 grams. Mass of the evaporating dish and the hydrate. The hydrate's the blue stuff. We said that weighed 146 grams. See how it's bigger? This number that you're going to get here should be in between these two numbers. 112.88 grams. Because this is the salt and the water. This is just the salt. Do you understand? Okay. Now, these 3 numbers you're going to get from calculations. These are the only 3 numbers that we need to measure in the lab. The empty dish, the dish with the blue stuff, the dish with the gray stuff. It's delicious. You know what I'm talking about? All right, good. Thank you. At least somebody knows. Don't eat it. Don't eat it. Don't eat it. I'm talking about Beauty and the Beast. The gray stuff, right? All right, so you're going to, this stuff is poisonous. Don't eat this. All right, so we got this blue stuff. Then we get it when it turns gray. That gray means there's no water left in it. And you're going to double check that by heating it multiple times. Okay. Mass of the anhydrous salt. How are we going to find the mass of the gray stuff?
You're going to subtract the mass of the evaporating dish from the final non-heating.
I love it. So the mass of the anhydrous salt is going to be 58.88. It's these two subtracted. How do I find the mass of the water? Bless you. Okay, I like it. 146 minus 112. Well, Megan's right on the ball today. So the mass of the water is going to be 33.12. And then how do you find the mass of the hydrate? Not minus. This is the salt without the water, and this is the water. How do I find the hydrate? Add them together. So 92 grams total. Or you could subtract these two. Okay? That will give you the 92, or adding these two together will get you the 92. Either one works. Okay. Then we have to determine the percent of water in the hydrate. How do you find percent of water? No, that's moles. Okay, so what was the part that was water? 33.12. What did the whole thing weigh? 92. Walters is on point today. And you get 36% water. Okay? If that number 36, if this number is 36, you are spot on. Not everybody's going to get 36. You might get 35.8. You might get 36.4. Okay? Because we are doing it experimentally. Experimentally, it opens ourselves up to many errors, right? You might have spilled a little salt. The little salt might be stuck on your stirring rod. You might not get all the water out. There's lots of things that there could be errors. If you get 36, you are spot on. Okay? Now, in this example, I got 36. Determine the percent error. Let's say you didn't get 36. Let's say you got 35.5%. That's just say, not using my numbers, you got 35.5%. How do you find percent error? It is in the reference table. Okay, the measured value, which in this case was 35.5. Okay, in my first case it would be 36. 36. The actual value is 36. That's what we should get. I'm telling you that. Okay, over the actual value. So 35.5 minus 36. Take the absolute value of that over 36 times 100. That's going to give you your percent error. If I use the 36, 36 minus 36 over 36 is going to give you 0% error. Okay? But you probably won't get exactly 36. If you do, give yourself a good pat on the back. Okay. Why is it important that the evaporating dish be cooled to room temperature before massing?
Because then some of the water can evaporate out.
Say that again. You don't want to. Some of the water could start evaporating. Well, there's a couple of reasons. When you put a hot evaporating dish on the balance, you're going to get convection currents. You know what convection currents are? Where they heat, and that's going to make the balance do this, and it's going to make I knew that's what you said. The evaporating dish could get you a different reading. So be careful. Also, we don't want you to burn yourself, so let it cool off a little bit. What? And heat rises. All right. What is the purpose of the second and possibly third heating? Make sure all the water's gone. All right. Now, 5 and 6. Calculate the number of moles of water in your sample. How many grams of water did I have? 33.12 grams of water. How do I change that to moles? See, it was 33.12 grams of water. How do I change that to moles? Yeah, and which is what? What does H2O weigh? 18 grams per mole. And so what's 33.12 divided by 18? 1.84 moles of water. Yes? Find the moles of salt, moles of copper 2 sulfate. How much copper 2 sulfate did we have? That's the anhydrate. 58.88 grams. 58.88 grams. What do I divide that by to get moles? Remember, the anhydrate is copper 2 sulfate. What's the gram formula mass of that? $160. Copper, there's one of them at 64. Sulfur, there's one at 32. Oxygen, there's 4 at 16. 64, 32, and 64 equals 160 grams per mole. Okay, so this is 160 grams per mole. 58.88 divided by 160, you got 0.368 moles of copper 2 sulfate. Now I have a mole ratio. This is how many moles of water I have. This is how many moles of copper 2 sulfate I have. What's my mole ratio here? Okay, I had 0.368 moles of copper 2 sulfate. You with me? And I had 1.84 moles of water. Those are ugly numbers. I want them to be in a whole number ratio. So what am I going to do? Divide by the smaller number. 0.368 and 0.368. What's the ratio? 1 copper 2 sulfate to how many waters? No, it's not 6. No, it's not 2 either. Oh, Lord. Do you have a calculator in front of you? No, don't use mental math. 5. You didn't. I heard 6. I heard 2. The only number I didn't hear was 5. All right. This may not come out to be exactly 5 on. This may not come out to be exactly 5 on yours. Why not? Because you might have some percent error. If you don't have percent error, you should come up with 5. Okay? If you don't, you still put the numbers you come up with. 1 to whatever number that is. And let's see how close you get it to be 5. Okay? And then name the following hydrate. Write the formula for the following hydrate. That I'm not going to give you the answers for. You could do those. Those are just easy peasy lemon squeezies. Okay?
Yep.
That's the whole lab. So, Walters, what's the first thing I'm going to do?
You're going to measure the plate.
You're going to measure the evaporating dish. Then you're going to come up to me and you're going to ask me for the blue stuff. After you get the blue stuff, you're going to measure it. So that you're going to get the dish and the blue stuff. Then you're going to do the heating, and you're going to get the dish and the gray stuff. Are you listening or are you talking? Okay? Those are the 3 numbers you need. You must be wearing goggles. No, don't give me, you're heating up a salt with water in it. That salt can spit out all over the place. So you're going to heat up the stuff. You're going to be wearing your goggles. You're going to heat it at least twice. Any questions? All right.